Question 61. Methanol is produced by the reversible gas phase hydrogenation. This is 2 of carbon monoxide. If you see the balance, both left hand side, right hand side, so this is 2. Um, and this is the stoichiometric equation. Carbon monoxide and hydrogen are charged to the reactor from here. That's a feed. And the reaction, let's say this is a packed with tubular, packed with reactor. Let's assume that, and let's assume what's coming out is at equilibrium. Okay, that means you have Y carbon monoxide, you have Y hydrogen, and you have Y methanol. Y stands for the mole fraction. That should be, if you add them up, that should be equal to, of course, 1, and these are in equilibrium, chemical equilibrium, gas phase. Process to equilibrium at 453 K and 2 atmosphere. The reaction equilibrium constant is given. So Kp is given as 1.68. Of course, this is a function of temperature only. That means at 453 Kelvin, at the reaction condition, mole fraction of hydrogen in the product. So this mole fraction of hydrogen is already given. That's equal to 0.4. Other one, we don't know. We don't know. Uh, Assuming ideal gas behavior. So this is a very easy problem. So this is taken from Smith, Van and Abbott. This, of course, is a product function. So basically what you have is, first we see the stoichiometric coefficient. This is -1, this is -2, and this is +1. And nu is, of course, is a summation of nu I, that will be equal to -1 plus of -2 plus of +1, and that's giving you -2. So if I write this one, product function, so this is equal to yi, so this should be equal to y of carbon monoxide raised to the power, its new y is -1, and then you have y of hydrogen is stoichiometric coefficient is -2, and then of course you have y of methanol, its stoichiometric coefficient is equal to 1. Okay, so that's a product function. So this is a product function, and this P is 2 atmosphere. So 2 atmosphere, and if you convert that to bar, it will be 1.013 bar atmosphere. We know, and this is P0 is the standard pressure of 1 bar, and so P0 would be equal to 1 bar, and it's raised to the power, and raised to the power it would be negative of mu, so it would be negative of -2. Okay, and then you have K, which is 1.68. All right, so this is easy, so we can write Y of methanol divided by Y of carbon monoxide and Y of hydrogen square is going to be equal to, it's going to be equal to 2 times 1.013 raised to the power. So this will be plus 2 into 1.68. Okay. Now, we all the y of hydrogen is given, is already given is 0.4. We have to find out y of methanol, mole fraction of methanol in the product. Okay, so that's what we have to find out. This one we have to find out. So we have to express YCO in terms of methanol, which is easy, as I said. YCO plus Y of hydrogen plus of Y of methanol is equal to 1. So all mole fraction added should be equal to 1. This is already given as 0.4. So therefore, Y of carbon monoxide is equal to 0.6 minus of Y of methanol, right? So we substitute here. So this becomes in terms of methanol. Other everything is known. So if you solve this one, y of methanol comes to be equal to 0.3117, and that is my answer. Detailed calculation, of course, detailed calculation is shown in our website.